I'm gonna run small video as well. That way I can focus on each place and I'll tell Vivek, hey, this is a discussion reference.
You want to video it now? We can video it.
Yeah, I'm videoing it. Let's see. Just to make sure he understands what we are talking.
Do you want to ask a couple of cases and we can video it?
Yeah, I can take a video. You can explain over. That's also fine.
So
the internet part at least you explain so that I can attach this video as it is.
Okay. So yeah, the internet part we haven't shown any of the VPN routers here. We've just shown the internet gateway, AES-222, the public AES out to the internet ISPs, the L3 VPN connections from the WAN aggregation routers, the WAN GRE routers that have got the private AES number out to the IBGP branches, and the WAN, an area border router for the OSPF branches. All of this is area 0. And so for the internet connectivity, any branch will come in here with a private 10 address. We've said that the internal addressing for the enterprise is 10. It will come across towards the internet, and we've said that the internal addressing NAT pool is 10/16, so we've just aggregated all the internal enterprise addressing. The external one, we've said for the gateway, there are 3 networks, 1/23, which is the LAN side to internet NAT pool. It's a 136.0.0/23. The /24 is 136.20, whatever we want to call it. Public IP range is just for this internet gateway, and the other one is a 10.0, which is just for this internet gateway. So when traffic from a branch comes through here, we have 2 default routes, either advertised with a non-forwarding route redistributed into OSPF, or it's learned via an OSPF or IBGP session, whichever way. This one is always primary, so it will come over via WAN aggregation 2 across the link between the 2 WAN aggregation routers, out WAN aggregation 1 to the internet gateway through the server set, get stateful firewalled and natted to this one of these addresses. So it will now appear as a source address of this, destined for say Google. It will go out this link. If this link fails, this router no longer receives the default route. It's now receiving the default route across this IBGP session from this guy. However, internally, this is still the primary gateway out. So if this link has failed, number one, from a branch point of view, it used to be coming in here. For VPN is taken down, so now the VPN is coming in this way. So before it was actually saying, I'll take that back, before it was coming in here, going across and out this firewall. If this link fails, the backup tunnel actually delivers that private addressing via the GRE here, comes across to WAN aggregation 2. WAN aggregation 2 is a non-forwarding route redistributed into OSPF with a higher cost than this one. Then it will still go across this link and through the stateful NAT and firewall. Again, the stateful NAT and firewall will now be learning the default route from this guy. He will follow over here and he will go out. To the rest of the world, this guy is no longer advertising this 36/23 out, so the rest of the world sees this guy as the owner of that. The return traffic will come across to this. This guy, again, will see the primary of this this route with the same method. We can do a non-forwarding route for this range, this /23. He will come across to here, go back through the stateful firewall NAT link, and be natted again to the internal address. So none of this has changed, and then he will go across to again to the backup one and across the tunnel, which is across here. So that's one of the failure scenarios, and we went through a number of others. L3 VPN, again, that's probably a little more simple, because if an L3 VPN site, if this link fails, an L3 VPN site entrance into this network doesn't change. It still just comes via still this primary link. He still folds over and goes out, across and out.
Okay.